associated with that are these incipient sutures. So you should know the left and right coronal sutures, and this one. Now, the correct term for this is interfrontal rather than frontal suture, or metopic suture. METOPIC, as we said last time. Now, also know the symphysis meant. No, I might not actually ask that on the on-screen test, but there's a possibility that I will. And the maxillary bones, but I'm more likely to ask the separate bones on the adult material rather than on this. The fontanelles are definitely not necessarily all of them, because that might be too many questions on fontanelles, given the total number of possible questions on the exam. But I will ask at least some of them. So if you can identify all the fontanelles, you'll be able to identify the ones I actually asked. So here's the anterior fontanelle in lateral view, and then here's an anterolateral fontanelle, also called a sphenoid fontanelle. And here is a posterolateral fontanelle, also called a mastoid fontanelle. And then one thing which has, in addition to the fontanelles, one thing that has a high probability of being asked is this. And remember, there's an error in the atlas with respect to that, because you can see even that this is still a little underexposed on screen. But I think you can see that there is a membrane here, rather than a hole. There's a membrane filling that region. And what that is a tympanic membrane. So you can say tympanum, or tympanic membrane, or if you insist, you can say eardrum.
Wait, so for that, do you want us to know as the external acoustic meatus or the tympanic membrane?
Well, what I'm saying is what you see there is not the external acoustic meatus, because there's no hole there, there's a membrane.
The hole is the meatus, the membrane is the...
Yeah, but there's no hole here. There's a membrane there. That's what I'm saying. That is a membrane. See, there's no hole. The hole appears later. So this is at about the beginning of the first trimester in embryonic development. And at this time, the eardrum is in the old reptilian position, that is right on the surface of the head. Later on, the external auditory meatus appears lateral to that. So as development occurs in the third trimester, the eardrum stays in place, but the skull grows laterally, and so lateral to the eardrum, a canal appears which opens on the surface of the skull, and the opening to that passageway at the medial end of which is the eardrum, is the external auditory meatus. But if this were a third, if in here, what you have here was a third trimester, a fetal skull at the beginning of the third trimester, about 7 months post-conception, you wouldn't see a hole here, you would see the eardrum. That's just because we repeat part of our evolutionary history in our embryonic development. So if you go into a pet store, or if you own a turtle, you can just look at the turtle you own, and look at a turtle in these green slider turtles, as they're called, and red sliders commonly sold in pet stores. You'll see a green region of skin here, a bright green region, or a red region, depending upon which species it is. That's the eardrum. There's no external acoustic meatus. The eardrum's right on the surface of the head. So that condition is repeated in our embryonic development. Okay. So labeling that the external acoustic meatus or external auditory meatus is a mistake, because you don't see a hole there, you see a membrane. That's the eardrum. And it's on the surface of the head at this stage. By the time birth occurs, however, there's a passageway lateral to the eardrum going to the surface, and then at the lateral end of that passageway is the external auditory meatus. And here's the anterior fontanelle from above, and here's that interfrontal metopic suture, or strictly speaking, what you should say is it's an incipient interfrontal suture or metopic suture, because the suture hasn't formed yet. The suture comes when the bones come together. But if you leave out the word incipient and just say interfrontal suture, I'll take that. And these are incipient coronal sutures. They eventually, when all four of these bones grow together and meet here, then you have a junction point called the bregma, which I will ask about the physical reality test. And then the two coronal sutures meet at that junction point and become one. But at this stage, there are separate incipient coronal sutures, and this is the incipient sagittal suture, and any of these things could be asked. Now, of the bones, I'm most likely to ask the frontal bones because of the difference between what you see here and what you see later on in life. When starting around 2 years of age, the interfrontal suture has formed and it starts to fuse. And then between 2 and 7 years of age, almost the entire thing will have fused in most people, and a good part of it will have been obliterated. And then by the adult stage, in 90% of the population, the entire interfrontal suture has been obliterated, but in a little less than 10%, there's a little remnant of it just above the place where the nasal bones meet the frontal bones. That's called the nasion. And then in less than 1% of the population, however, the entire interfrontal suture persists throughout life. So if you're a radiologic technologist for long enough, it's likely that at some point you'll get an image where you see a separation between two frontal bones over here, and some people will say, oh, look at that, there's a fracture there. But what it actually is, and if there's a fracture here, you'll see the bone actually broken up. But if you see a neat separation right over here, it's a persistent interfrontal suture, which persists in some people, less than 1% of the population. And I have a skull with a persistent interfrontal suture, which I will show in class. I'll have that out on Thursday, that I got by pure good fortune. Okay, so now that you've heard about this, you'll know what you're looking at when that comes up. And remember, it's important, I'll take that question in one moment, to know about these things, because if you look up expert systems on YouTube, search for expert systems, you'll see what's happening. That is software called an expert system. This is what's called artificial narrow intelligence, ANI, as opposed to artificial broad intelligence, which is a long ways off. But right now we already have artificial narrow intelligence, where you have what's called an expert system, which has enough intelligence to do a particular job in a particular industry or area of practice. So this has happened in the auto industry. You can take a look what's happened in the auto industry. Most of the assembly line workers are gone and have been replaced by robots. You can see this in the YouTube presentations. And so what's left are computers running expert systems which run all the robots, and a small number of highly paid IT people who supervise what the expert system is doing to make sure it isn't making a mistake. Okay, so that's what's happened already in the auto industry, and then it's already happening in things like radiologic technology. I've been told by some of my former students that there are hospitals in this area where the machine sets itself up, and all the technologist has to do is position the patient. But positioning the patient is something that could be done by a less highly trained and lower paid person. How long does it take to learn to do that? So you have to be careful, because if that's all you know, you can be replaced by somebody else who's getting paid a lot less money. And this is not going to happen next year, but you can see that it's coming, because there are already machines, MRI machines, that set themselves up. And you just have to position the patient. So they may eliminate the more highly paid individuals and replace them by lower paid individuals. So, but if you add something extra, so you're like those IT people in the auto industry, where you can read the screen. So a mistake is made, and if the person telling you what the image they need is like a first-year radiology resident, the chances of mistakes being made are relatively high. Fewer mistakes are made as you go into you dealing with second-year residents and third, and then fourth, and then fifth-year residents, and the chances that an attending will make a mistake are fairly low. But mistakes are made, even by them. When they're having a bad day, they have had a bad night because of persistent upper respiratory infection, they're coming on 3 hours sleep, they may make an error. But if you're knowledgeable, you can see that an error has been made because the screen is showing things that other than what they need to see. And then you can speak to them, tell them what the situation is. Because if you don't, then the attending who gets the image will say, this doesn't show what I need, so do it over again. And they'll blame it on you rather than the resident. So being knowledgeable is important. So this is coming within your career time. So the more you know, the better. And you can't rely on common sense to do it, because common sense can mislead you substantially. Because after all, it's common sense that the Earth is at the center of the universe and everything rotates around it. Because all you have to do is just look up in the sky and the sun appears in the east. The sun, quote, rises, end quote, in the east, and then crosses the sky and sets in the west. So it's obvious that the Earth is not moving, it is in the center of the universe, and everything rotates around. But, you know, it's counterintuitive that that's not the case. So you have to be knowledgeable to know that. It's also counterintuitive that the Earth is round, although some very intelligent people, even in the Roman world, could see that the Earth was round. There are things that they saw when they were out at sea, away from land, that told them that the Earth was round, that landlubbers didn't see. But to most people, common sense told them that the Earth was flat. It's obvious that it had to be flat. So you can't rely on common sense, especially in a technical field like this, because a lot of things can be misleading. So that's my recommendation. Then now, if you get everything right on the exams coming up, then you'll know that you're a skull master, and also a master of the axial skeleton, and you know the vertebrae as well. And that's very helpful for reading screens. Okay. And then you should know the posterior fontanelle also. The anterior fontanelle is anterior to the sagittal suture. Here's the anterior fontanelle, and here's the sagittal suture. Anterior is that way. And then if you go to the back of the skull, posterior to the sagittal suture, you see the posterior fontanelle. And you should know the incipient lambdoid suture as well. Okay. And then this is the squama of the occipital, over here, which you have to know on the adult one also. So I went past a question while I was making a comment. Question?
I was trying to ask what was the bragma? Where you said the bragma was located?
The bragma?
Yeah, is that what it
The
was?
bragma. Take a look at the osteochronology handout, which you have in your handout collection. It's called the osteochronology handout. It's a text handout. It's not one you just got, it's one you got a while ago.
Writing on.
Yeah. Look for the osteochronology handout. It's a one-page handout. I thought I just saw it as you were turning. That's it. Yeah, that looks like it. You got that? Look at the one he has. Show her that one. And you'll see the bregma on it.
No, where? I was asking where were you pointing that it was located?
Oh, I'll show that on screen again. Now, the bregma isn't there. The bregma forms when the anterior fontanelle has been eliminated.
Okay.
Okay. Yeah, so here is this is the apertures handout. There's also an osteochronology handout, which is a one-page handout. Try to organize your handouts. I recommend having a.
Okay.
You see that? You see the bregma?
Yeah.
When these four bones grow together. When these four bones grow together, these start as what I'll call focal points of ossification. In a radiograph of an aborted fetus, you can see at a certain stage little dots.